So in Chapter 11, we've talked a lot about where the water comes from and where it goes and how it cycles, as well as how we can access it and use it, right, with aquifers and wells and all of that from 11.3. But one thing that we haven't really talked about is who is currently using it, how much of it they're currently using, as well as pollution. So pollution is obviously a major issue, and pollution doesn't necessarily have to be some nefarious scheme carried out by a corporation. Pollution can happen accidentally, right? There's a little bit of litter, there's trash, or it could just be runoff, right? Every car has a little bit of a leak, right? Some kind of leak of oil or windshield wiper fluid, or somebody that dumps a soda out of their car or something like that, right? Not even the can, but just pours out some soda. That, while nobody would really consider that pollution, that's going to have a different level of acidity and sugar and different chemicals and stuff in it that, if enough of it gets into the water source, it's going to, have some tiny little bit of an effect. But these tiny little instances, right, every car having a tiny little leak, a bunch of people dumping out sodas or whatever, all of that kind of adds up and forms what we would call a non-point source solution. Or non-point source pollution, not solution. So non-point means that it's coming from runoff, right? It could be from farming, right, with nitrogen and phosphorus. They use those as fertilizer on pretty much every field. And when that fertilizer enters a waterway, enters a river, enters a pond or a lake, that is essentially like fish food or algae food. And that can create what we call an algal or an algae bloom, which causes a huge increase in the amount and rate that the algae are growing. And they can essentially use up all of the oxygen, or potentially block the sunlight from getting through down to plants that are down at the bottom of the river or lake. So they can have huge impacts on the ecosystem. If they use up all the oxygen, there's no oxygen for the fish and the plants that live there. If they block the sunlight, then those plants that are further down can't get any sunlight and survive. We were already talking about streets, right, that every car has a little leak. But if there's thousands and thousands of cars driving, those little leaks add up. And as they drain out into the ocean, or out, into a river or wherever, that's going to have some major impacts. Additionally, erosion, which can happen naturally, or it can happen because we're building too close to waterways, or because we're, pushing sand in different places, or if you build a house close to the beach and then that beach starts to erode. That's a natural process that happens. Beaches build up and then they erode away. That's been happening for, forever. And so that erosion can add and remove material into and out of a source or a river or something. And that can also change how that waterway looks and feels. If there's more erosion in there, it gets what we call turbid. Turbidity is essentially how cloudy the water is. Cloudier water means that it's harder for things to grow. It's also harder for things to seed in there. Plants have a hard time getting sunlight in really turbid waters. So non-point source pollution can be from a number of different places of a number of different types, get into rivers and lakes and oceans in a number of different ways, and have a huge number of effects. Point source pollution, the first one here, is the one that we normally think of. It comes out of a pipe. It comes out of a factory, right? You can pinpoint exactly where it's coming from. That's not necessarily less common, but those point sources are highly regulated, right? Certain factories are allowed to put out certain amounts and certain types of waste into waterways, but those are highly regulated. Whereas non-point source pollution is much harder to regulate because that's any water that gets washed into any waterway. So anytime it rains and the roads get cleared up of the oil that's kind of built on them, that goes into our wastewater treatment system. A lot of that just goes right out to the ocean because we can't treat all of that water. So not only are we kind of wasting fresh water, but we're also basically just dumping that non-point source pollution, runoff pollution, right out into the ocean. So we try to clean as much as we can. We have sewage treatment plants, and so those are just big factories that clean the waste material. They do it through a lot of settling, right? They get the water into a tank, they let it get really, really still, and a lot of the stuff, right, whatever that stuff is, falls out of suspension and sinks down to the bottom of it. They also do it through filters. They add chemicals. They do lots of different stuff to it. Septic tanks are usually used at more of a household level in areas where they can't connect to a sewage treatment plant. So a lot of places in slightly more rural areas will be on septic tanks. If you're down on the Cape, a lot of places are. Essentially, it's just a large underground tank that collects and cleans wastewater. Again, pretty much through this process of letting the water start to settle. And as it settles down, it drops out of, it drops all that junk, all the stuff that you might end up in a septic tank. It all settles down to the bottom, and it's going to filter through dirt and sand and the material that's already down at the bottom underneath the house or the yard. And as water filters through dirt, it naturally gets cleaned. That's why aquifers are such good sources of clean fresh water, because, as that water filters down through layers and layers and layers and layers of dirt and sand and clay, that dirt and sand and clay collects all the other crud, and the water that ends up down here is really, really clean. So, we try to treat as much water as possible, whether it's to drink again or whether it's just to add back into a lake or river or pond or wherever. But we can't clean it all. And a lot of it ends up, especially if you're in a coastal area, it ends up back in the ocean, which just further reduces the amount of fresh water that we have. If you're interested in non-point pollution, a really interesting and turbidity, you could look up Merry Meeting Bay. That's a pretty good topic for you. Mr. Kalman in his youth did some research on that. So water uses, where does all the water go that we're talking about here? So if we're talking about houses, right, in your house, bathing, toilet, and laundry. So taking a shower, flushing the toilet, and doing laundry accounts for about 60% of the water on average across all households in the United States. Then we've got watering lawns, car washes, and pools accounts for a third of the water. The remaining 8% is drinking and cooking. So, to drink tap water, to boil water for pasta, to cook whatever, that's only 8%. So 60% of your household water is from bathing, toilets, and laundry. So how can we reduce water use in the household? Where should we look? Should we really look at drinking and cooking? Probably not, right? Those are things that we have to do. You have to drink water, you have to cook. So let's just ignore that 8%, right? Lawn watering, car wash, and pools. That's a third, right? That's pretty big. That's a lot of the water use. So, why, do you really need a pool? Probably not. How often do you have to wash your car? Probably not all that often, right? Like, you really need to. If you live on the East Coast and it gets all salty in the winter, fine, get a car wash. But you probably don't need to do it. Leave it out in the rain. That'll clean it. Watering your lawn, of course it's nice to have a nice looking green lawn, but, we got to think about the cost. Maybe do it a little bit less. Rather than 3 or 4 times a week, do it 2 or 3 times a week. But this 60%, that's nearly 2/3, right? We're going to call that almost 2/3 of the water use, comes from the bathing, toilet, and laundry. So I'm not telling you not to take a shower, but rather than a 10-minute shower, maybe take a 5-minute shower. If you can cut that 5-minute shower down to 4 minutes, you've cut your shower water usage down by 20%. That's going to have a pretty big impact. Obviously, you got to flush the toilet, so we'll leave that one alone. That would be gross. But with laundry, make sure that the laundry is fully packed, right? Don't just run a half load or a quarter load. Run a full load every single time. Wait an extra day until you actually have enough clothes to be doing your laundry. So simple things like that, cutting a minute off your shower, making sure that every load of laundry is a full one, can make a big deal, since that kind of water use accounts for 60% of the household water use. So what we have down here is overall use in the United States. This is, from 2010, so yes, it's 10 million years ago. I started reading here. It's 10 years ago, about. But this gives you, I'm going to pause the video or me talking here so that you can get a better look at where most of the water is going. So the big four, we've got thermoelectric power. So that is using water to cool down electric generators. Number two, irrigation. That's huge, right? You can kind of lump this red from livestock in with that irrigation, because that's all farming. Along with this aquaculture of this blue. So all of this is farming of some sort, right? So that's a huge amount there that actually probably would come relatively close to equaling thermoelectric if those three were combined. Number three is public supply. So that's what we use, public supply, meaning normal people. That's essentially what we have for the bathing, toilet, laundry, lawn watering, drinking, etc. So that kind of gives you an idea that most of the water use, if the public supply is this tiny little bit right here, right, is number three, that's what we use in the public supply. Everything else, all the rest of this, comes to some type of industry other than normal people, right? It could come to thermoelectric, mining, industry, it could come to farming, but only this little bit here, really, this is just getting confusing, only this little bit here is used for households. So the places where we can really, really save water is thermoelectric and is irrigation and farming, right? Farms, that's a huge one. Now granted, farms are, we need to be watering our crops, but there are different ways of doing it. There are different ways of irrigating your crops that don't waste quite as much water as other ways. If we can figure out a better or easier way of cooling down this thermoelectric power and reducing some of the water use, even if rather than just being as big as it is now, but we were able to shave it by this much, right? That we could save for the public supply and keep that kind of aside, that'd be a huge reduction. Right, so when we're looking at where we can save water, if you're thinking about the household, it needs to be bathing and it needs to be laundry. If we're thinking about overall across the United States, we've got to be looking at irrigation and farming, as well as some of these industrial uses, including thermoelectric power. So the last part that I want to talk about here are some of these fast facts. While 70% of the Earth is covered with water, only 2.5% of the water on Earth is fresh water. Then only 1% of that fresh water is accessible. The other 99% is in ice caps and snowfields. So in conclusion, only 0.007% of the planet's water is available to humans. That's nothing. Right? Now granted, that's still a lot of water, but when you're thinking about 7 billion people, that's not a lot of water that we've got. Average American uses 176 gallons of water per day. Right? Now yes, that is factoring in water of doing the dishes, even if you don't do the dishes. Or if your sister takes a 30-minute shower and you take a 60-minute shower, they're averaging you and your sister and your brother who takes 5-minute showers, right? They're averaging all of that together. So on average, the average American uses 176 gallons of water per day compared to the 5 gallons used by the average African family. Pretty big disparity there. Nearly a 30 times, or actually more than a 30 times difference in the water usage. 2.4 billion, that's with a B, billion people lack adequate sanitation, meaning cleaning up the water that they have. So that's more than a quarter. That's actually just about a third of the people on Earth. About 34% of the people on Earth don't have adequate sanitation. 1/7 of the people on Earth, 1 billion people, lack adequate access to clean water, meaning they're drinking dirty water every day. So this is kind of a gross fact, but diarrhea has killed more people in the last 10 years than all of the wars since World War II. That's crazy. Since World War II ended in 1945, diarrhea has killed more people in the last 10 years than all the wars since 1945. So 1945 comes around, and every war until 2018 has killed fewer people than diarrhea in just the last 10 years. Now granted, it's horrible for anybody to die, whether it's war or diarrhea, but it's crazy that a lack of access to clean water passes germs and diseases around, and then causes diarrhea that kills people, and kills that many people. So what I want us to think about is groundwater truly renewable? To answer this, think about the short-term scientific aspects of this question, such as the water cycle. How long does it take these aquifers to truly recharge? If we're thinking about, especially if we're thinking about what we've done with paving, right, and what we've done to the surfaces that normally should be permeable, meaning allow water to go through, but now are impermeable and divert runoff and infiltration. Also consider the rate of water use. So think about some of these facts up here. And how long it takes to build up an aquifer. Write some bullet points below about whether or not you think groundwater is renewable. Some of these facts should help guide you as you choose a topic for your project. So remember, keep in mind that this whole time we're coming back to this essential question of how can we encourage those around us to be more responsible water users and protect others from pollution. So that question allows you to research any number of interesting water use problems. Keep that in mind.